The next speaker, one of the 6 most important pioneers in robotics, Peter Corke.
Thanks, Seth. I borrowed some words from Jan, talking about the robotics toolbox, tools for the analytic robotics age. Has anybody here used the robotics toolbox? Oh, that's heartening. Wonderful. All right, what I want to do today is just tell you a little bit about why it was created, why it's the shape that it is, and where it's going. All right, the origin story. Everyone loves an origin story. And this goes to why I did a toolbox for MATLAB. Long time ago, really kind of my first big major job, I was part of a project to use a Puma robot to grind metal. Right? Puma robots are exactly the wrong sort of robot to grind metal. Right? We needed force control and all that stuff. So I got involved in a lot of engineering. That's me. Reverse engineering the Unimate controller. We did tons of system identification of the motors, the power amplifiers, the gear trains, the dynamics in the drive shafts, and we built a new controller from scratch. And to do system identification in 1986, MATLAB and Leonard Lung's system identification toolbox was the way to go. So that's why MATLAB. As part of the same project, I built a new controller using a 32-bit microprocessor, which was kind of new and cool back then. And this is really the first time that I wrote a package, a framework for doing robotics. So it's the first time I kind of wrote all the functions in C for creating rotation matrices and multiplying rotation matrices and quaternions and all that jazz. So the first time I did all this stuff, it was in C in '86. I did my PhD kind of late in life, and for that I needed tools that I could use to prototype visual servo systems, analyze data and all of that. MATLAB was very familiar. We had a license for it at the place that I worked and at the university, so I started building functions to enable my own work in MATLAB. And that there is, at the top there is the function for creating a canonic rotation matrix, SE3 matrix for rotation around the x-axis. It's dated 1990. That's the oldest MATLAB M file in the toolbox, and started off with some fairly rudimentary animations. But at the time, in the early 90s, they were pretty cool. I would also say that the toolbox reflects the era in which it was created. The very first generation of robotic textbooks, which are shown there, did everything in terms of homogeneous rotation matrix, homogeneous transformation matrices, which today we call an SE3 matrix. So today we have a richness of representations that we use in robotics, screws and matrix exponentials and quaternions. But back when I started, the books that I learned from was 4x4 matrices and Euler angles. It was kind of impoverished. And so over time, the toolbox has grown all these extra representations and the conversions between the different representations. In 1996, I was still a relatively young robotics researcher, and I was invited to my very first symposium on robotics research. And so this is where the great and the good of robotics get together every 2 years. It's quite a who's who of people in robotics. This one was in Germany. I was kind of in awe of the company that I was amongst. But I took my little toolbox on a laptop and showed it to a few people there, and they were very encouraging, which was good. And encouraged me to open source it. Back in 1996, that meant you put it on an FTP server. The times have changed a lot. And I was also encouraged to write an article about the toolbox, which appeared in a 1996 issue of the Robotics and Automation magazine. So that's when the toolbox really became a thing. Over time, the toolbox has gotten very entangled with my book on robotics. What happened there? This is kind of spooky. I'll just stand here. There we go. So the toolbox has had numbers of different versions. There was the initial version 4, which was the first public one. John Craig approached me about using the toolbox for the examples, the problem sets in the 3rd edition of his book. So that led to version 7 of the toolbox, where I had to add modified Denevert-Hartenberg parameters. I already had Denevert-Hartenberg parameters, and I think that's where my distaste for Denevert-Hartenberg parameters really set in. It's been my lifelong mission to stamp them out ever since. So there's been relatively few releases over time. They've mostly corresponded with big events like first edition of the book and second edition of the book is when a lot of effort goes into updating the MATLAB version of the Toolbox. On the software front, things have changed along the way. In 1996, MATLAB got objects. Before that, it didn't have objects at all, so that led to some changes in the Toolbox. The Toolbox was everything that I thought was cool. So early days, it had vision functions as well as robotic functions, so I factored them out in the early 2000s, and sometime there, but 2016, I added classes. So instead of just representing an SE3 matrix as a normal MATLAB matrix, which is a completely general 4x4 matrix, as a class enforces everything that makes a matrix an SE3 matrix. And then sometime later, I factored out all the functions that did manipulation of the fundamental representations that went out into spatial math Toolbox. People ask me a lot, is the Toolbox really open source? So I distribute the source code for my Toolbox, but you can't, and you can read it and you can change it, but you can't run it unless you buy MATLAB from the MathWorks. And people also ask me a lot about Octave, which is kind of a MATLAB clone, but I admire the Octave people and the effort they put into it, but it's got quite a number of significant differences with the MATLAB from the MathWorks. The object system has got subtle nuances and differences, and the graphic system is really completely different. So supporting an Octave version and a MATLAB version really was, I did it for a while and then I gave up. So next part I want to talk about the developments that have happened in parallel at MathWorks. I've used MATLAB for almost 40 years, and I've had an association with MathWorks for more than 10 years. I've met Cleve Moeller a number of times. Cleve's the mathematician who developed the MATLAB language, and I did a sabbatical at MathWorks in Boston in 2018. During that sabbatical, I proposed to the MathWorks people that they should build into MATLAB representations for the things that we roboticists find useful. SE3 matrices, unit quaternions, twists and rotation matrices and all these things. They've gone part of the way along this journey. So there is now in MATLAB a quaternion type, and they have SE3, SO3, SE2, and SO2 classes now built into MATLAB. Some of them require that you buy special toolboxes to get them, but they are now built into MATLAB. So I feel I've had some influence in nudging them in that particular direction. They've got a number of teams working on a whole bunch of toolboxes that are relevant to this community. They're listed there. And what I did over the last few years was to write a third edition of the book where I have retired my old toolboxes, the ones that I started in 1990, and the book now uses only the toolboxes that are provided by MathWorks. So this is a totally proprietary solution, and the book was co-authored with two colleagues and friends from the MathWorks, Remo and Vitek. And in some ways, it's a rational decision. MathWorks have got thousands of people developing code, and for me, it's just me every other weekend working on the code, so it's going to be much better for the users. But to have all of this locked up with proprietary tools does leave a little bit of a sour taste in my mouth. So that then leads on to the Python toolboxes. This is what I'll finish up with. So it was clear that an completely open version of a toolboxes was going to be a good thing. And you can see here the popularity. MATLAB's the line bumping along the bottom. The black line is Python, and the orange line is C++. So over the last decade, Python has been rising and rising. MATLAB is rising a little bit, but not at the rate of the other two. It's interesting, actually, Python's quite an old language. Python 1 came out in 1991 when I was writing the first version of the toolbox. But back then, I'd never heard of Python. but it's sort of come from nowhere over the last decade or two. And I had 2 failed attempts to create a Python version of the Toolbox, one in 2008, another time in 2017. Then a few things happened. In 2017, I won an award for university teaching and had quite a handsome prize. So I had some cash. A PhD student, Jesse Haviland, started with me, and he started to noodle around with some tools to support his PhD. I'm only his advisor. I can't tell him to use MATLAB, so he started writing stuff in Python. And I thought, this is crazy. We should join forces, and together we could create a robotics toolbox. So I had some cash. I had Jesse. And then this happened. We all had a lot of spare time. So in that period, 2020 to 21, where it was just a really fevered effort in producing code and writing a Python version of the book. So timeline's been extended. In the pandemic era, we cranked out three toolboxes, and 2 versions of the book came out in 23. The completely proprietary MATLAB version and the completely open Python version. So the book comes out, you can install all the code, pip install RVC3 Python, done. All the toolboxes and all their dependencies come in. It's a bunch of toolboxes, the robotics toolbox, the vision toolbox, all the spatial math stuff's in a toolbox of its own, Seth stalking, AI Institute looking after the spatial math toolbox now, which is great. And now there's lots of toolbox and book options. Mixed openness, no openness, full openness. So I'm kind of happy with that particular outcome. So take-home messages. The original mantra, the motivation of the toolbox was to allow a user to solve complex problems with small amounts of code. That's still relevant today. I worry about code bloat. I don't think it's big in our field, and I don't think it's good. If you do open source software, it can be a good for yourself and reputation-wise, also a big impact on the field. I would encourage you to do that. At some point, any code base needs to be discarded. All right? It's just got too much cruft and layers of patches. You just got to throw it away and just take the good ideas. And I would also observe the software development tools have changed out of sight over 30 years. The then and the now. You probably haven't even heard of the things in the then column. I'm going to stop. Thank you, Seth.
We have time for questions for Peter. Any questions for Peter? And it's really hard for me to see the audience, so wave your hand wildly. Oh, there's a wild question over there.
Yeah.
Great talk, Peter. And I just want to say how much of an inspiration you've been to me in terms of all the great things you've done for robotics education, for Ross. And the robotics toolbox has been a huge inspiration for the things that I've done in the classroom.
Thank you.
I really loved at the end where you had, what was before and as a VI user myself, I appreciated that. The one thing that I was saying is in terms of curriculum and what students should learn and, what's changed now in this new era of Copilot and GitHub instead of FTP sites. What do you think is changing in our curriculum that we tell students they need to learn to be a part of the robotics community?
It's a really good question. In my job at the university, I taught engineers, right? And for me, getting them up to speed with ROS was just a bridge too far. I think if you're in CS and teaching robotics, ROS is probably something that you would teach because they understand the principles of threads and parallelism and concurrency and all of that. So when we teach in 3rd and 4th year units, we don't teach ROS at all. I think it's too complicating. There's some advanced kids who already know it, and I just let them go, but for the rest of the class, I wouldn't push them that way.
All right, thank you.
You're welcome.
Let's thank Peter again.